Our next and final speaker in this section is a world-known consultant in the area of computer security for health data, recently named one of the most powerful women in health information technology, our own Dixie Baker. Thank you, Dixie. Dixie has been with the Global Alliance from day one, and we're very appreciative.
All right, I'm gonna, I'll be talking today about a task that was jointly undertaken by the GA4GH Regulatory and Ethics Workstream and the Data Security Workstream. And the topic was privacy preserving linkage of genomic and clinical data sets. The task was launched in 2016 as a collaboration between GA4GH and the International Rare Diseases Research Consortium, or IRDIC. And it was tasked to address ethical questions, regulatory requirements, and technical methods and approaches to around privacy-preserving record linkage. The primary motivation of this work was the conviction that by having the capability to link data in a privacy-preserving way, we could improve the quality of data for research and healthcare, but while at the same time it would, in some ways, contribute to privacy risk. The deliverables from the task were an ethical legal primer that Bartha led the development of, and a technical primer. To illustrate, you might ask yourself how record linkage could improve data quality, and I tried to come up with a rather, trivial example of how that can happen. Here you see 6 records, all associated with the same individual, Joe. Joe did quite a bit of traveling. He traveled to Australia and Europe and Africa and North America. And the first capability that privacy-preserving data linkage can do is it can identify that here we have duplicate records, 2 records that are associated with the same individual, and by identifying that these are duplicate records, we can avoid double counting or counting that individual as 2 different subjects in a research project. So secondly, by linking these data, we can create a much richer data set for research. And without disclosing the individual's identity, you notice that this data set that we've created up there in the right-hand corner is not labeled Joe, but it's labeled with a pseudonym. So it's a coded data set. So it hasn't disclosed the individual's identity, but it has created a much richer data set. And then finally, Finally, the third benefit of PPRL is the fact that it can enable the re-identification of an individual, either for the purpose of return of results, or if the research produces a medically actionable result, to get back to the patient to the individual so that they can benefit from that new knowledge. So the PPRL task force, the 3 challenges that we undertook were to identify a method that GA4GH could possibly use to identify duplicate data, to link data to create richer data sets, and thirdly, to re-identify the individual when necessary and authorized. The members of the task group were a very diverse group. Bartha and myself and Petra Kaufman from NIH, we co-led the task team. And Mark Phillips, who's a colleague of Bartha's at McGill, was also a key member of this task team. David Enkevork from the University Medical Center of Groningen in the Netherlands was a key member. Hans Lachmuller, who's one of the directors of ERDIC, was a key member of this task team. And finally, Domenica Taruscio from Rome, Italy, was a member of this task team. The ethico-legal primer, I should ask Bartha to come up and explain, but the ethico-legal primer identified challenges in the law in 4 different areas. And the first was sensitivity considerations. Linking data increases the target value for cyber terrorists. It makes it more attractive. And we know that health data has become more attractive for cyber terrorists. Also, aggregated data can become identifiable. You put enough information available, information together, and it can imply the identity of an individual. And these 2 sensitivity considerations really support the notion that data linkage can improve the quality of data. Secondly was that the means of generating the linkage data are addressed in a number of laws. There are legal requirements that prohibit the use of mandated universal identifiers. In fact, that's true in the US. We cannot have a universal national patient identifier. The GDPR actually allows the adoption of a uniform patient identifier, but few countries have taken advantage of this capability. And other laws actually prohibit the use of linkages that are derived directly from identifiable data. Again, this is in US law. HIPAA does prohibit the use of protected health information to create a code or a pseudonym for a limited data set. The third area is participant withdrawal. The GDPR explicitly requires that a participant consent be as easy to withdraw as to give to begin with. And we all know that retroactive, and law throughout the world recognizes that retroactive withdrawal is generally not possible. And then the final area that was addressed was the returning results to participants. And this is probably the most complex area of the law that they discussed in the primer. There are re-identification in some law and return of results. It may be prohibited, and in other law it may be mandatory. And the participant's right to know may need to be enforced. So the law there's a wide variation in the law around returning results to participants. The technical primer specified the technical requirements, GA for GH technical requirements for privacy-preserving record linkage. And it explored the linkage protocols that are widely used, the techniques that are used, and it looked at approaches that have actually been implemented. And in looking at all of this, we finally the group got together and we concluded that the European Patient Identity Management approach, or EUPID, was closely aligned with our requirements, but at the same time, we recognize that there's a need for further work on it. At a very high level, this is the EUPID and how it works. One of the real beauties of EUPID is that the pseudonym are context specific. So there's a negotiation between the linkage server and the client, and they agree upon the specific data elements that they're going to use and the methods they're going to use, like the hash algorithms they're going to use, whether they're going to encrypt or not, and they negotiate this, and then they associate that with a pseudonym. So the local client runs these methods on the data elements they've agreed upon and returns the values back to the server, and then the server returns the pseudonym, which is context specific. So it's linked specific to that context. And by context, I mean specific hospital, clinic, research project. And so these pseudonyms are context specific, and that's important. And that linkage between the pseudonym, the context-specific pseudonym, and the actual identity of the individual is kept locally. So the linkage server doesn't have that linkage at all. The linkage server, on the other hand, keeps these linkages between the hash values and the encrypted values and the pseudonym, and maintains those in an index. And it also maintains the pseudonyms that really link back to the same individual in what they call the EUPID. So the EUPID contains the pseudonyms that their algorithms have determined are linked. So the researcher, if they've come up with a coded record and they want to find other coded records that relate to the same individual, they'll query the EUPID server, and the server will come back and point them to the pseudonyms and the contexts where they can then go directly to request the data. So the linkage server has no knowledge of exactly who the individual is. So we really, and there's an optional re-identification component as well. So, conclusions. Every known PPRL technique makes some use of individually identifiable data. And the use of individually identifiable data is regulated throughout the world. So this area is a very, very significant challenge. Second, that no technical solutions alone can both enable data linkage and protect individual privacy. The technical solutions must be accompanied by strong policy and strong governance. And then the final was that the EUPID approach looks to be the most promising for GH, but there are certain limitations. First of all, it hasn't been totally implemented. For example, one of the largest needs for the development is there's no query API into the linkage server right now, so that needs to be developed. Secondly, there's never been a security assessment. They've never looked at federation, which we would want to do. And there also are two single-point failure vulnerabilities there, one being the linkage server and the re-identification trusted third party. So we would want to look at that and how to eliminate or at least mitigate the risk associated with those single-point failure. And with that, I'll turn it back over to David.